Let's talk about Kfold cross-validation. Quick recap, we have seen leave one out cross-validation in a previous video and the disadvantage of it. Leave one out cross-validation, what do we do there? We take n-1 data points as the training data and the nth data point we take that as the validation data. This is one of the iterations and we repeat the iteration by changing the data which goes into the validation data. So we take each individual row and one at a time we take that as the validation data. So we run n different iterations. So n iterations of the model says run, and finally we aggregate their output. So this is the final error. This is the final error that we take as the leave one out cross validation error. Now this has a disadvantage that we are running n iterations of the model. So imagine if you have 10,000 rows in your data, you would be running 10,000 different iterations. So this would be painfully slow, and hence we cannot proceed with leave one out cross validation. So an alternative to that is Kfold cross validation, which is very popularly used. So all non-parametric models, in fact, they almost always go through a process of Kfold cross validation. So this can be used to tune the parameters also. So for example, we were talking about the min bucket parameter or any other parameter in any algorithm. We can always tune the parameters. Tune the parameters is used to denote finding the right value of the parameter which neither underfits the data nor overfits the test data. So that can be done using Kfold cross validation. So let us see what is Kfold cross validation. So if we have n data points, let's say we have n data points in our training data. So we will still have our test data, which is a general process we will always follow. We will always have a test data set. Now from the training data, what do we do here? We divide our data sets into k folds. Folds means k parts. We divide our training data set into k parts. K is usually taken to be 5 or 10. So let's say we are assuming k to be 5 here. So I will divide my n rows into 5 parts. Let me call it fold 1, fold 2, fold 3, fold 4 and fold 5. And almost always these parts are comparable, they are equal. So if you have n points, if you have 100 points, you will have 20 in each of them. So these are the 5 folds that we have now if you have taken k to be 5. Now what do? We start with some iterations. So in the first iteration, we take the first 4 folds as our validation data, as our training data, sorry. So let me write here training and validation. So we will take fold 1, fold 2, 3 and 4 as our training data, and the 5th fold will be the validation data set. So we will build a model on this data and allow it to predict on the validation data. Or if we are tuning our parameters, we will train our model on this data and we will find out the best value of min bucket, which gives the best accuracy on this 5th fold. Now we repeat the process. So we will have F1, F2, F3 and F5 here, and we will take F4 as the validation data. Similarly, all possible iterations we will do, and you will see that we will have a total of 5 iterations. So F4, we will have F3 and F2, and finally we will have F1. And here we will have and finally F2, F3, F4 and F5. So these are the different iterations we will run. Now if you look this carefully, you will see that we are running only 5 number of times. Only 5 iterations we are doing. So this is not as bad as leave one out cross validation, where we were running it n number of times. So here we are running only 5 times, and your final cross validation error, your cross validation error will be 1 by 5 of all the errors that the model makes. So you take the average of the error. Now this can be used for parameter tuning. You can tune your parameters based on what is the parameter which in general gives the best score on the validation data. So for each value, so let's say we are talking about a parameter, let's say this is the parameter that we are talking about. So for each fold or for each iteration from here, we will plot the accuracy. So let's say this is the accuracy on y-axis. So for the first iteration, let's say this is how it looks like. This is the accuracy for the first iteration. So accuracy on first fold, let's say. So if you see the parameter when it is small, when the parameter is small, your model overfits. This is where overfitting happens, and this is where underfitting happens. So if the parameter value is small, your model overfits. This is the best. This is the sweet spot. Similarly, we will do for the other folds also. This is on F1. So this is for this particular iteration I have drawn. Similarly, for other iterations, you can have similar graphs. Let's say this is for F2. So for this iteration, I have drawn the green one. Then you can have others as well. You can have, let's say, one more. This is blue one is for F3. Let's say pink one is for F4, and you will have the last one which is for F5. So let's say this is for F5. So finally you aggregate the results, and on an average you will draw a line which will be the average of all of them. So let's say this is the average of all of them. This is the average line, and you will find out what value of parameter is best for this average. So this is the parameter value. This is the parameter value which is best for all of them. So this is the parameter that you will finally select for your model. So your model will be trained based on this particular value of parameter, and using that model you will predict on your test data. So this is the process of Kfold cross validation. Quick recap. In Kfold cross validation, we divide our data into K folds. These K folds are generally equal in size. So if you have 100 rows of data and you divide your data into 5 folds, you will have 20 data points in each of the folds. You take K minus 1 folds as your training data and the kth fold as your validation data, and you repeat this process until each fold becomes your validation data. So you will see that you will be performing K iterations in total, and finally you aggregate the results. So the accuracy the overall error will be average of errors made by all the 5 iterations or all the K iterations. Kfold cross validation can be used for parameter tuning. So what we do is we plot the accuracy with respect to different values of parameter, and finally we average out the result, and for the average result, whichever parameter works out to be the best is finally selected for the model. In the next video, we will see how to implement Kfold cross validation in R.